In this video, we're going to talk about some more stoichiometry stuff, and this is the concept of yield. Yield could mean a lot of different things. We're thinking about here yield in terms of amount of product that is formed, okay? And it's interesting, well, maybe not interesting to you, but or to anybody, but um, it's it turns out that even if you do everything perfectly right, you don't always get 100% of your stuff. Your reactions don't always go to completion. Sometimes there's side products, there's byproducts, or it just doesn't work very well, and you're you don't get a complete conversion, and that's okay, and that happens, and we're fine with that. Sometimes we're just happy we got any product at all. Um, but this is why I want to talk about the yields. Okay, yields are talking about the amount of product that's formed in the reaction. Um, we're going to talk about three things with yield. First up, theoretical yield. Theoretical yield is important. What's important to know about theoretical yield, this is the max amount of product that is possible. Okay, that phrase should sound familiar. We used this before when we're talking about limiting reactant. Okay, the theoretical yield is always a calculated amount that's based off of the amount of limiting reactant that we have. Okay, so when we're talking about theoretical yield, we're always talking about something that's calculated, um, and it's based off of how much limiting reaction is there. The theoretical yield is how much you get. Crap, sorry. The theoretical yield is how much you get if the reaction goes to completion. Okay. All right. Which ideally we would hope that, but in this world that doesn't usually happen. Um, all right. The other yield we're worried about here is the actual yield. Actual yield is data, right? This is what you happened in the lab. This is the amount of product we got by doing the experiment. Okay. The actual yield is measured. Okay. So when you get in the lab and do the experiment, you will measure the amount of stuff that comes out. That's your actual yield. This may or may not be, and most likely probably won't be the same as your theoretical yield. Hopefully, it's probably less than your theoretical yield. If it's more, then something wacky happened, but we'll figure that out. Okay. Um, and the last thing we're going to think about is a percent yield. Percent yield gives us an idea of how good our reaction was. Did we get close to 100%? Um, did we get like 5%? Sometimes reactions are complicated and it's good to get a 5% yield. At least you got something. Sometimes you screw up and you get a 0% yield. We just want to know what that is. When we get into the lab, and I tell my organic chemistry students this too, that you don't want to think about percent yield like a grade. Okay. It's not like, oh, I got a 70% yield. That's really bad. Okay. Uh, no, 70% is great, right? We're not going to think about that too very much. We're going to focus on is calculating these things. How do we work with yields as we do this? All right. Let's just dive right in. Here's an example. This might look similar. We did this in another video. 7.36 grams of zinc, 6.45 uh, grams of sulfur. We're making a note here to say in the lab, this many, 8.776 grams of zinc were obtained, and we want to know what is the percent yield. So we probably want to know what the theoretical yield was. Okay. Remember, the theoretical yield is the max amount possible. And we determined that already by determining the limiting reaction in another video. And we found out that was 11.0 grams of zinc sulfide, right? Because we said that zinc was limiting. Okay. So we can label these things. Your max amount possible um, is your theoretical. In the lab, so this is your actual. Okay, and we're solving for percent. So we want to remember that your percent yield is equal to the actual divided by the theoretical times 100. And in most scenarios, this should be less than 100, okay? Unless something weird happens and you're in your lab, you might actually calculate something more than 100%. There's probably contamination or something going on. You did not violate the law of conservation of mass. Anyway, actual over theoretical. So that is 8.7766. What the hell's going on? 6 grams. 6 disappeared. Divided by 11.0 grams times 100. Okay. So this ends up being 79.7818%. Okay. Because our theoretical yield only has 3 significant figures, we can round this and say this is 79.8% yield. Okay. That works great. Don't be married to the ideal that the percent has to be a whole number. It doesn't. It just has the correct number of significant figures. I'm going to write that here so we'll see it too, right? I'm going to have the correct number of significant figures on your percentage. Okay. All right, let's take a stab at. Oh, I didn't have to write it out. It was right there. I'm so lame. All right. Anywho, this was from that previous video. All right, let's do another example. All right, this is a little bit more interesting. Not interesting, but maybe complicated. 2.60 times 10 to the 3 grams each of calcium oxide and carbon are reacted in this reaction. And we want to know what is the max amount of calcium carbide that can be produced. Okay. We are asking a follow-up question that says, if we made 2,850 grams of calcium carbide, what is the percent yield? So this is a combination thing now. We have to do the limiting reactant problem because that's going to figure out the theoretical yield. So this first part is going to identify for us the theoretical yield. Okay. And we're going to do this exactly the same way as we did before. I've given us some molar masses, and we're going to solve for grams of calcium carbide and go from there. Since calcium oxide is written first, I want to do that first. It doesn't really matter. 2.60 times 10 to the 3 grams calcium oxide. Okay. We're given the molar mass. 1 mole of calcium oxide is 56.08 grams of calcium oxide. Formulas everywhere, everywhere, everywhere. Our equation says 1 mole of calcium oxide will give us 1 mole of calcium carbide. And then 1 mole of calcium carbide is 64.10 grams of calcium carbide. Okay, I gave us the molar mass so we don't have to stress about it. Okay, let's do the other one. It's the same starting amount, 2.60 times 10 to the 3 grams of, not calcium this time, this is just carbon. Too many C's in one problem, geez. Okay, let's see, carbon is 12.01 grams of carbon for 1 mole of carbon. You can grab that dude off the periodic table. Our equation tells us that 3 moles of carbon will give us 1 mole of calcium carbide. Okay. And that, again, we have to end with the same thing we ended with before. So 1 mole of calcium carbide will be 64.10 grams of calcium carbide. All right. If we solve these out, starting with calcium oxide, we'll end up getting 2,970 grams of calcium. Made it worse. Calcium carbide. And if we start with carbon, we'll end up getting 4,630 grams of calcium carbide. All right, now we have to figure out which one of these is the actual answer, right? Remember, the smaller one of the two is our actual answer. So this is the answer. Make sure you mark it, circle it, put a star by it, underline it a bunch of times, whatever. Okay, so this is the max amount. Okay, so remember, that's our theoretical yield. All right, so the next question says, if we have 2850 grams of calcium carbide that is produced, what is the percent yield? So we know our previous one said that we could make 2970 max. All right. Remember, the max amount is your theoretical. What you get in the lab is your actual. And our percent yield is actual divided by theoretical times 100. Okay. We know the actual is 2850 grams. We know the theoretical is 2970 grams. So we did pretty good. Look at this, times 100. With 3 significant figures should be 96%. Yield. You don't always have to write yield. I like writing the word yield, but there it is. Okay. So the big thing here, we have to remember what the difference between theoretical yield and actual yield are. The big difference is theoretical is calculated, actual is measured. Okay, actual yield is what you got in the lab. Theoretical is the max amount possible. Okay, that's it for yield. I'll see you back. I got one more stoichiometry video, and that's going to be a big example to wrap everything up. Just give you one more shot of looking at all this stuff. Okay, I'll catch you later. Let me know if you need anything. I'm here.